All right, we're reviewing for Monday's quiz, and this will be on Chapter 11, Sections 1 through 5. All right, so let's start off with Section 11.1. All right, what did we learn in Section 11.1? In Section 11.1, we started with interior sum and exterior angle sum. So we talked about a triangle, which is a three-sided figure. We talked about a four-sided figure. We talked about a five-sided figure. And we talked about a six-sided figure. And we could go on forever and ever, but I'll stop with those four figures. Three-sided, four-sided, five-sided, six-sided. All right, so there's two concepts that we should understand for each figure. We should understand what the interior angle sum is and what the exterior angle sum is. Does someone remember what the interior angle sum of a triangle is? I heard someone say 180. I heard someone say 360. The interior angle sum is 180. So in a triangle, the interior angle sum is 180. So let's go with that. So let's go to the next figure. Four-sided figure. Interior angle sum is. And do you remember why the answer is what? So what's the answer and why is it the answer? The answer is 360. Why? Because I can break a four-sided figure into two triangles. All right? And how does this pattern keep going? A three-sided figure has one triangle, interior angle sum 180. Four-sided figure can be broken into two triangles, interior angle sum 360. A five-sided figure can be broken into three triangles, interior angle sum 540. A six-sided figure can be broken into how many triangles? Four. Interior angle sum 720. And what was the formula that we learned? You always take the number of sides, subtract 2, multiply by 180. Let's double check it. What's 3 minus 2? 1 times 180, 180. 4 minus 2 is 2. 2 times 180, 360. 5 minus 2, 3. 3 times 180, 540. 5 minus 2 is, said that wrong. 6 minus 2 is 4. 4 times 180, 720. This formula works for the first four figures that I put on. Second question. If I don't draw a figure, but I just tell you, hey, what is the interior angle sum of a 12-sided figure? And I picked 12 for a reason because we should be able to do it in our head. Plug it in. 12 minus 2, 10. 10 times 180 is 1,800. So without even drawing it, you can figure out the interior angle sum of a 12-sided figure, or I could give you a different number, and you can plug it in. All right, let's back up. Second concept, exterior angle sum. When I taught this, I put an imaginary triangle on the ground, and I walked around it. I put a book on the ground, which is a four-sided figure, and I walked around it. What did you notice when I walked around a triangle and when I walked around a book? I walked around how many degrees? 360. So in a triangle, the exterior angle sum is 360. In a four-sided figure, the exterior angle sum is 360. In a five-sided figure, the exterior angle sum is 360. In a six-sided figure, the exterior angle sum is 360. In a 12-sided figure, the exterior angle sum would be 360. In a million-sided figure, the exterior angle sum would be 360. It's always 360. Questions on the first section? All right. Moving a part of this section and part of the next section. Well, actually, we're moving to the next section. The next section is finding the area of a regular polygon. Finding the area of a regular polygon. So let me draw a regular five-sided figure. Let me draw a regular four-sided figure. And let me draw a regular six-sided figure. What's the word regular mean? All sides and angles congruent. So I'm going through here and I'm marking all sides congruent, and all angles would be congruent. Now, when we talked about finding the area of a regular figure, now this is a four-sided figure, and I have a formula for that. I look at my formula sheet, and area is length times width. But if I look at a five-sided figure, and I look at my formula sheet, is there an area formula for a five-sided figure? No. If I look at a six-sided figure, I look at my formula sheet. Is there an area for a six-sided figure? No. So what we have to do is break a five-sided figure into five equal, and I'm doing a pretty bad job right now of trying to draw equal, five equal triangles. And in a six-sided figure, I'll try to do the best I can, break it into six equal triangles. All right. I know, it's pretty bad. You can laugh. Get on it with it. Here we go. Now, there's a reason why I did this. There's a reason why I did this. In a five-sided figure, if I drew it a little better, it would look more accurate. But these five angles are equal. Who's got to work to find one of those angles? We talked about it in class. How many degrees in a circle? 360. And I broke it into how many equal angles? 360 divided by 5 is 72. Each of these angles is 72. Six-sided figure. 360 divided by 6. Answer, 60. Each of these angles is 60. Now, what I will probably do on Monday's quiz is draw one of these figures and tell you, for example, let me change colors here. I will tell you that, hey, this triangle right here has an area of 2 square centimeters. How do you find the area of the whole thing? If one triangle in a five-sided figure that's broken into 5 equal triangles is 2. Tara, multiply by 5. So 2 times 5, answer, 10 square centimeters. Moving on. If I tell you in the six-sided figure that a triangle is, give me a number, 7 square inches, 7 square inches, what's the area of the whole thing? The area of the whole thing is 7 times 6, answer, 42 square inches. So this was the second section on finding, this is section 11.2, and we were working with regular polygons. Questions on section 2? All right, section 3. In section 3, we were working with ratios. So what we did in this section was we drew figures. I said figures. We draw figures that are similar. So I'm drawing 2 rhombuses that are similar. Now, when they are similar, the sides are in proportion, and the angles are congruent. So in this figure, I'll say that this is rhombus, and it has a side of 1 inch. And this is a rhombus, and it has a side of 3 inches. And I want to know the ratio of the sides, the ratio of the perimeter, and the ratio of the areas. And we will look in terms of small to big. So what's the ratio of small to big of the sides? 1/3. And does anybody remember if the sides are 1 to 3, the perimeter is also 1 to 3. But the area, what do you do to the perimeter and sides to get area? Square them. So the area is 1 squared is 1, 3 squared is 9. Let's do one more problem. Let's do one more problem. Let me draw a 5-sided figure and another 5-sided figure. And we'll say that this is 2 inches and this is 5 inches. And this time, instead of doing small to big, let's do big to small. And let's look at sides, perimeter, area. Who's got the ratio of the sides? We're looking at big to small. Answer. Tara says 5/2. Kyle, the perimeter would be 5/2. Gabe, what would the area be? 25/4. Now, the extension question that I could ask is the following. Let's go back to the original problem. If this area is 2 centimeters squared, what's this area? If this area, I don't know, but this area is 25 square centimeters, what's the other area? So let's finish these problems. Top problem. 1/9 equals, who can finish 1/9? 1/9 equals. Now 1 is small, 9 is big. What's 2/x? Solve it. 18 equals x. I just figured out this area is 18 square centimeters. Finish the second one. This one's going to be maybe a little harder. 25/4 equals, now this is big to small, 25/x. Oh, this might be easier than I thought. 25 times 4 is 100. 100 equals 25x. Answer is 4. The answer is 4. Questions on this concept? That leaves us with section 11.4 and 11.5. 11.4. 11.4 talked about circumference of a circle and the arc length of a circle. Arc length is the distance partway around the circle. And can someone give me the general formulas? How do I find circumference of a formula? That one would be on the formula sheet. And Tara looks at the formula sheet, and circumference is, can't read it, she says. Derek? 2 pi r. Now, does someone remember what I do to the circumference formula to get the arc length formula? Because I'm only trying to find a fraction of the whole thing. It depends on the problem. It depends on how big of the circle you want to try to find. So it's not always divided by 4, but it's always x over 360 times 2 pi r. And then I've got next section, 11.5. Area of a circle, and then area of part of a circle. So area of a circle, pi r squared. And let me draw a better picture because you're asking what in the world is that. So let me draw a whole circle. And again, let's pretend that I want to find the area of part of it. Instead of giving you something easy like half of it, let me draw a part of it that's like, let me say that it's 120 degrees. What's the formula that I use? Area of this sector. Now I use the pi r squared, but what do I got to do to pi r squared? I use the same thing over again. X over 360. All right. So I'm giving you 4 problems to do. I'm giving you 4 problems to do. And here's the 4 problems. I have a circle, and I also have part of a circle. Call this 80 degrees. So here's my 4 questions. In the top circle, I will say that my radius is 5 feet. In the bottom circle, I will say that my radius is 6 feet. Here's my 4 questions. What is the area of the whole circle? What is the circumference of the whole circle? What is the arc length of this part of the circle that has an arc of 80 degrees? And what is the area of the sector of this circle that has an arc of 80 degrees? I will pause it to allow you to finish those 4 problems. We'll check back in a minute or 2 with the answers. Okay, so you can see the work for all 4 problems, and you can pull out a calculator and get the exact answers. You can take 25 times pi on a calculator. Gabe. You can take 10 pi on a calculator. You can take 80 divided by 360 times 2 times pi times 6 on a calculator. And you can take 80 divided by 80 divided by 360 times pi times, it would actually be 36 on a calculator to get the exact answer. So again, quiz on Monday on these concepts, and to finish class as a practice problem, we worked at doing some problems when you had to figure out what to do. So let's pretend at my house I have a garden box right here, and also in this garden box I put a circle. All right. So here's the concept. I have a couple questions that are related to this last concept that we went over. If I draw the radius, and I tell you that the radius is, someone give me a number. I'll go with 8 feet. That sounds good. Gabe wins, 8 feet. I have 2 questions. I want to know the area of the circle I want to know the area of the square, and I also want to know the area of the shaded region, and that's the area between the circle and the square. So I have 3 questions in class, and I want you to complete these 3 problems on a scratch paper, and you cannot leave class until you show me the answers. So area of the circle, area of the square, and area of the shaded region. Good luck. Show me your answers in a little bit.